Hi, everybody. What I want to do over here is discuss the structure, how we might think of arrays. Now, arrays are one of the basic fundamental data structures because you have a position, you have a reference to those positions, and then you can go contiguously in memory. That means that they're next to each other, and you get position 1, 2, 3, 4, and you can store information in there. And you can even reference those positions by that information by the positions that they're in. And there's a lot of tricks to do with hashing and other things like that based on recognizing those positions. Now, the thing with arrays is that it's very good at random access. That means that you can get a position, but it's not very good at doing things like insertion and deletion. So I'm going to create a generic system, that's why I'm using the diamond brackets with a T. And my generic system is going to model arrays, but it's going to have rules for like insertion, deletion, and things like that. So I'm going to have an initial value is going to be a private int, which is going to be the size. And that's just going to be whatever it ends up being. We will set it up though. And then I'm going to have another private thing, which is going to be of type T, and it's going to be called, we'll just make it elements, which are going to be the information that I have up here. And then I'm going to have my constructor, and my constructor is going to be my array list, because that's basically what I'm modeling, really, my array list. And if you create this array list, what's going to happen is we're going to create elements, and we're going to say that elements is going to be of type T. And what you have to do is you have to convert it to this from object, and that's one way to do this. And if this is empty, then I'm going to assign a size, and I'll say that size equals just like a default of 10, and then I will give it size. Now, the this is going to be my default setup. Now, I can have another constructor which will do the same thing, but take in a size, and presumably that's not not an unreasonable thing to have my array list and then have an in size over here, and then you can take in size when you do this, and I'm going to assign this dot size is going to be assigned size, and then I'll be safe doing that. So I have two constructors. One is when you give me the size, and one is not. Now, the next thing, what I want to do is start to model what I might do with this. So for instance, I might add information. So the first thing I want to do when I add information is not just to be saying add an element, but what I want to think about is, what if this thing is too big? So if you need to resize it or make it bigger, that's a function that I probably am going to need ahead of time. So I'm going to say, this is actually going to be a private function, private void resize. And resize is going to be a function that's going to say, assuming that you don't have room, then you are going to resize it. So I'm going to get some new capacity, and that new capacity is just going to be filled in. So I'm going to have a new size. I'll just call it new size. In new size is going to be equal to 2 times size, 2 times this dot size, just so we know which one we're talking about, but I could just say size and it's okay. But I have that, and now what I need to do is I need to just make a new array that's going to basically be that type. So it's going to be it's going to be an array of type T, and it's going to be called. So I'm going to have to rename elements when I do this. Um, I guess I could copy one into another in order to do this. There's a couple different ways I'm thinking of. The problem is, let me just explain why I'm hesitating here, is that if I create a new array, right, what I need to do is I need to then fill it in, and so I do that, but then that's not called elements, right? So what I have to do is then assign elements to that, right? So I need to create it and then assign elements to that. And so that's what I'm going to do over here. I'm going to do it step by step instead of using any libraries. So this is going to be T, and since we're just calling everything, new size, I'm going to call this new elements as well, even though new can sometimes be problematic. And then I'm going to set it up the same way that I did before by making this an object, and this size is simply going to be new size. Okay, So now what I need to do is simply copy the information in, and it's going to be of size new elements dot length, because that's what we have. And new elements dot length is now I'm going to assign each position in here. So I'm going to say new elements of I is going to be equal to elements of I. And now that I have copied over all that information, now what I need to do is set elements equal to new elements and size equal to new size. So this is going to be the resize function. The reason I need it is because if I want to go add something, so I'm going to create a function called public void add, and you're going to give me some information to add in, whatever it might be. I don't know what type it is, but you're going to give me something for my elements. So I'm going to have, I'll just call it info that you're going to give me. And I'm going to need to say like elements of the next open position, right? So the next open position. So what is the next open position? So I'm going to need to keep track of how many positions are available over here. So what I'm going to do to keep track of that is simply create something that's going to keep track of positions. So I'm going to say position. Now position is going to be a int, and it's going to keep track of it. So if I have an array of size, then when I create this, position will be 0 because I have not filled in any values yet. So when I have this, even though there are spots in there, position is 0. Now, if I resize this, what size is position? Well, position is going to be, position didn't change because position is going to be whatever it was. So if position was, there was 10 things that you actually had in there of pieces of information, then position will still be 10. It's just that that's going to, so if I need to know how big elements is, I mean, if I need to know how much information is in elements, then I'm going to go to position and say elements of position is going to be info. So I'm just going to assign elements of position, which is really basically just counting where we're up to, is going to be info. Now, the question is, what about if it's full, right? What about if it's full already? So then I'm going to have to figure out a way to deal with that. Now, I already created a resize thing. So if, what I'm going to say is that if position is the same as size, right? In other words, if you filled it up enough that there's nothing, that there's no more space here, then I'm going to say, resize and do that. And so if position is the same as size, which means that the size of the array is going to be, let's just say 10. And then position is, it should actually be position plus 1 because position is going to always start from 0 and size is going to be just the size of the array. So it'll be an array of size 10, but that means it has spots 0 through 9. So if position plus 1 is equal to size, then I need to resize it. And once I do that, I just say elements of position is going to be info. Now, every time you add something, then the position is basically going to be where you're up to. And so now I'm up to the next empty spot. So position plus plus. So now that I'm up to the next empty spot, I'm going to just add 1 to position. So I have to make sure I'm consistent over here because position now means the empty spot, right? Position is going to be my empty spot. So 0 was the empty spot and I fill it in. Now I'm at the next empty spot. So if I'm testing over here, this is the empty spot. So if position plus 1 is going to be the same as size, because if 9, let's just imagine, right? We have to go through each case. If I filled in 0 through 9 and 9 is now full, so then position is at 9, but then this means that position goes to 10. So I don't really need to add the plus 1 anymore, I'm realizing, because position would be really where the empty spot is. So if you're at size 10, that means you have no more spots, and we need to do that. So if position is a 10, because that's the next empty spot, and there's no empty spot there, because it's the same as size, then resize. So it's always good to think through these scenarios. Now, that's a position, if I want to add. If I want to do other things like, let's say, get a position, then I would do something else. I would say something like public, and what type are you going to do? I'm going to say get, and you're going to give me some index wherever you are. Now, I do need to really make sure that it's not out of bounds, but I'm not going to talk about that right now because I just want to simplify this. So I'm going to say elements of index is just the thing that it's going to return. So it's important to recognize that all we need to do in order to create our list is we would go to main, and let me just show you what it's going to look like over here. So I'm going to create my list. So my list is called my array list, and I'm going to have it of type integer or double or whatever, but it's got to be uppercase because these are wrapper classes that we're going to be using over here. And the wrapper classes means that you're not going to be using the int and double, because these are like, make sure that everything is, well, there's a bunch of reasons, but let's just call it list safe. And I'm going to say new my array list, and I'm just going to make an empty list. Okay. Now I have the option of saying list.add, and I'm going to add an integer, which is going to be the number 5, like that. And so I have my function over here, which does add. And so I'm able to then access that function and do add. And if I wanted to know what's there, then I could do something like system.out list dot, and you can see I have my add function that I've created. I also have my get function, and it's going to get at position 0, let's say, and then I should be able to do this. So I don't know if this will work. I probably should have checked before running this, but it does work, and I'm able to get that. Now, one of the things that I might want to know separate from this is, what about if I want to insert at a certain position? So that's really what I'm trying to get to. So you could imagine that we can have functions like add, we can have functions like get, and I should really add one more, which is that I want to have a function called remove, which is going to just remove elements, because this is a little bit easier to set up. So I'm going to say public void remove, and then you're just going to tell me which index you want to remove, because if you want to remove something. So how would I do that? Well, first of all, I have to make sure that it's actually legal to remove it, but in other words, like it's not out of bounds in some way. But avoiding that, I'm going to do a for loop, and it's going to really just start at whatever index is, and I'm just going to write over it. So it's going to go from index. Let's say you said you want to remove position 5, so it's going to go from index up until elements dot length. It's going to go up until the end and keep removing it. So if I had a position over here, then I'm going to now write over. Okay. So how do I write over it? I'm simply going to say that elements of I is going to be equal to elements of I plus 1. So I'm just going to write over each of these. Now I need to keep track of that, because now whatever position it was, I have to say that position, which is the thing that's keeping track of everything, is going to be 1 less. So position is going to be 1 less than whatever it was. And I also want to make sure that nobody sees information in that last element. So I need to make it something so that way it's clear that there's no information, you don't write over it or go in there. So I'm going to say elements of, well, whatever, wherever I was, is I'm going to assign it to 0. So elements of position, I should probably do this first. Elements of position, which was the last spot that had information, which no longer has information, so I'll do this first. Elements of position is going to be equal to null or null pointer or something like that. So that means that the last position, which is the one that's now, which is you're at some position, you're generally at the empty position. So the way we decided to do this is that you're generally at the empty position. So now 1 less than that is empty. So I'm going to go minus minus, and 1 less than that becomes empty, because you were at position, let's say 8, and that was empty, whatever number position was. So now I'm going to go 1 less, and I'm going to empty that position. And then I set position equal to 1 less than that, because because now that position is empty. So in other words, you were at the empty. So the one before that is now empty, and right. So and I just need to, well, I guess the truth is this should change position at the same time. So I don't need to do it in a separate step because it should affect position also. Right. So let me just write it in a separate step just in case, because sometimes there's things that can happen that make this challenging. So you were at position, let's say 8, and now you're going to go to position 1 less than that, which is position 7, and then you're going to empty that, and that's going to be the first empty spot. So that's going to be our system. Now size hasn't changed because size is however big the array is. So now I have a remove system to set up. Now the next thing I want to do is to talk about an insertion. Now insertion is very important because you have to move everything over, but now you have to just keep track of it as you go. So first thing is you cannot insert if it's too big, right? You cannot insert. So I'm going to have public void insert, and you're going to give me a info, and it's going to be of type T over here, and you're going to give me an int index about where you want to insert. So first thing I have to check is this full? So just like before, I have to say if position is the same as size, then I'm going to say resize and just make sure that we're okay. So now we're assuming that we have enough space to put this value in, and that's going to be very important. The next thing to do is to put it into that position. So I'm going to say a for loop going from that position. So I'm going to go with wherever index is. Now, the thing is, the first thing I need to really do is move everybody over. So I'm going to say index up until, now, the truth is, I don't need to, over here, I don't need to go to the end if I'm just going to move everybody over. Even though there's space for it, I really only need to go up until whatever position is. So in other words, whatever is the last spot that's empty. So I'm just going to go up until position. Before, when I did up until the end to remove everybody, that's just assuming that potentially to move everybody backwards by 1, that's just assuming that, potentially it's full, but it doesn't really matter if it is or it isn't. So this, I'm just going up to position, but I could have done it differently. I'm just going to position because that's the last piece of information that's there. So if it's less than position. So what's going to happen is I'm going to move everybody over. So the truth is, if position is the same as size, then I need to resize it. But it's really, even if that's not really true, because that would mean, oh, okay, that is true, because that would mean that it's full, then I need to resize it. I was just thinking a different scenario, but okay, so I need to resize it if it's full. So now I know that it's not full, and I need to move everybody over by 1, and then I need to just fill it in afterwards. So I'm just simply going to say that elements of I plus 1 rather is going to be assigned elements of I. Now let's see if this makes any sense. I'm going to take wherever I am, and I'm going to move it over to elements of I plus 1. So in other words, the I plus 1 position, let's say position 6, is going to get the info that's in 5. The problem is that I can't just do that because now I lost the information that's there, right? I lost the information that's supposed to be in position 6. I need to actually keep track of that. So why don't I create a variable to keep track of that? So I'm going to create it on the outside in case I need it on the outside. So I'm going to call it holder, and I'll just set it to 0. And so initially what I'm going to do is I'm going to say, well, if you are in elements I plus 1, that needs to be stored somewhere. So I'm going to say that is holder, and it's going to be of type T because I don't know what anything else is over here either. So holder is going to be of type T. The problem is that it needs to match everything that I have. So when I do insertion, I can't just say it's of type T because who says that that's going to be a 0 when I do that? So over here, what I'm going to do is just assign it to be a null because I don't know what type it is, but I don't need to worry really because whatever it is in elements, which is of type T, that's going to, which is going to be position I plus one over here, if I'm keeping track properly, then that's going to be of type holder anyway, of type T, so that's perfectly fine. So first, I'm going to put that, let's say, position whatever 6 is, I'm going to put that into holder. And now I'm going to assign elements of I to I plus 1. Okay. And then what's going to happen in the next loop? Then I'm going to have to, so I have the holder. I'm going to have to put holder, which is going to be which is going to be in the position, into, which is the 6, into the next one. And then so I'm going to really have to have two things to keep track. So I'm going to have holder 1 and holder 2. So holder 1, I'm not sure. Let me see if I can explain this better, but holder 1 and holder 2. So there's a better way to do this, which I'm going to show you afterwards, but this is important. So I kind of see that the first thing I'm recognizing as I develop this is that elements of I plus 1, which means the next spot, needs to be stored somewhere. Okay, and then once you store that, now you can put into elements of I plus 1, you can put into elements of I plus 1, you can put in element of I. So that's fine. But the question then becomes, okay, so I put in elements of I into that position and I stored that. So then in the next loop, I'm going to take holder and I'm really going to put it into elements of I plus 1, right? So I'm going to take holder and I'm going to put it into elements of I plus 1 after storing it. So really, I'm going to need two variables. So I'm going to write this and show you what the setup is. That way we can kind of visualize it a little bit better. Okay, so I fixed this up to show you, and let me explain how this works. I think the easiest way to do this would be with a picture. So let me show you. But let me just first mention that elements of index is going to be assigned to holder 2 initially, right? Sorry, it should actually be to holder 1. Elements of index should be assigned to there initially, and this will be null. Okay, so you kind of need to do this, but like I said, there is a better way to do this. So I'm going to pick up paint and show you a picture. So if we have, hopefully everyone can see, if we have spot 1, spot 2, and spot 3. Now, the question is, what do we need to do? We need to basically just empty this first spot. We need to go and empty the first spot. So the way that I'm going to do that is I'm going to put this value into holder 1. That was my initial, I'm just going to write H1 for holder 1. So I did that. And then inside the function, I'm going to then go put this spot into holder 2. So I'm going to just write H2. Then holder 1 goes over here. Okay, so I assigned it to I plus 1 position over here. I assigned it to I plus 1 position. And now what I need to do is I need to rename this holder 1. So I rename this holder 1. That's just holder 1. Just going to write it over a bunch of times. Maybe it'll be clear. Could also just erase it, obviously, but I see that 2 underneath it. Anyway, that's holder 1. And then I make this holder 2. And then this is holder 2. And then holder 1 can be put in over here. And then now that that's there, I could rename this holder 1. So I get rid of that and I rename it holder 1. And then I keep going. So the only trick is that I need to do this on the outside. I need to do this assigning of holder 1, index to holder 1 over on the outside, because otherwise it would always just assign whatever index is to holder 1 and I'd lose the previous information. So this is the way that I set it up to do an insert. So this works, but let's just see if we did everything that we need. We've assigned it, and now that we've emptied that, we can take index, whatever index initially is, and I can say elements of index now is empty because we pushed everybody over, and then I can plug in info, and that's perfectly fine. And then I also have to say that position plus plus position is going to go up by 1. So this would cover everything. Now, there's a better way to do this, which I want to mention, which I'm going to just create a new public void insert alternative, and you're going to give me t info, and you're going to give me int index to do this. Now, it's better if you go backwards. So what I mean to say is start from wherever position is. So start from wherever position is, wherever the position is -1 will be the first spot that has information, and go as long as you're greater than index. And every time you do it, you're going to be minus minus. So assuming there is a spot here, and if there isn't, then I'm just going to throw this in over here. I'm just going to throw this in. And now what I'm going to do is I'm simply going to move everybody over by saying that elements of, and this is, remember, this is the, I'm going to, well, I'll actually start from position because that's fine. So elements of I, which is the first empty spot that I have, is going to simply be elements of I minus 1. So it's going to be the previous information. So now everybody's moved over, and you went up until index, and then you can go and say that the end of this, which is right here, which is that. So the trick to this is that sometimes it's easier to kind of think if you work backwards, because now we don't have to keep track of everything, because I just have an empty spot at the end that I don't need to worry about. So this would be an alternative. The point of this whole exercise is that, one, we should explore generics, at least start to think about those and how they might work. But two, the second thing is to show that insertion and deletion in an array means I have to make sure that I move everybody over. If I don't have enough space, then I have to make sure to double it or something like that. So this is how it would look to set everything up in terms of thinking about arrays and how they work.